All right, as promised, we've got a little bit more algebra stuck in the middle of geometry. We've got lots of algebra that sneaks into geometry, which is good for some of you because many of you prefer algebra to geometry anyway. And so we talked about some more stuff with parallel and perpendicular lines and all those kind of things in our last lesson. We talked about slopes and all that stuff was going to come in handy in this lesson as well. In this one, we're going to kind of review a topic that is kind of a type of problem where we're given some information and we're expected to find an equation of a line. We're going to jump in with examples straight away and take care of that. So our first example is, this is probably review. If it's not, we're going to do several examples in here. So hopefully we'll either dust off cobwebs or we'll get you where you need to be and all of those things. You can, if this is the first time seeing this and this feels like a struggle to you, you may want to check out my Algebra 1 videos on this topic as well. If I remember to do it, I will link that in the iCard on here on YouTube. So our first problem is write an equation in slope-intercept form of the line with slope 3 and y-intercept of -2, then graph the line. So the first thing we need to remember is, what is slope-intercept? Oops, would help to have the right tool, huh? In slope-intercept form, what does that mean? So what is slope-intercept form? Well, that, in case you have forgotten, is y equals mx plus b, where m is the slope, right? And the b is the y-intercept, or where the graph crosses the y-axis, right? Probably, hopefully, maybe you've seen this before. If not, then that is slope-intercept form, okay? So let's look at what we're given. In this problem, this first one is super duper easy because we're actually given the slope and the y-intercept. So all we have to do is plug those where they go. So the equation of this line would be y equals 3, because that's where the slope is, next to the x, minus 2. Okay. Now, then we're asked to graph the line. We're going to practice this as well. We're going to do it several times. So if you remember, this is the y-axis, the vertical axis, and the horizontal axis is the x-axis. So we've got axes. Let me add a underlayment here. This is the x-axis, and this is the y-axis, right? And so we start, when we're graphing from slope-intercept, by putting a dot at the y-intercept. So that's what we're going to do first. We're going to put a dot down here at -2. Then we've got to count the slope. And slope, if you remember, is rise over run. So we're going to go up 3 and then over 1. So we're going to go up 1, 2, 3 over 1. And then we are going to do that one more time, up 1, 2, 3 over 1. You're going to grab your straight edge. I'm going to do the best I can with what I have, because I don't exactly have access to a straight edge here, but we're going to connect the dots using magic. All right, you're going to graph, and then there is your line. So that is our first example. Let's look at another one. We'll kill that off. Oops. I put those in the wrong layer. That's okay. I'll fix that later, or I won't, but you'll never worry about it because you'll be done with this by then. Okay, we're going to write an equation in point-intercept form. That's a typo. It should not be point-intercept form. There's no such thing as point-intercept form. It should be point-slope form of the line with slope -3, 4 that contains -2, 5, and then we're going to graph the line. So we looked at slope-intercept form. What was point-slope form? Where point-slope form is y minus y1 equals m, that m is the same as the other m, times x minus x1. So this is still the slope here. The m is still the slope. And then y1, x1, y1 is a point on the line. Okay, that's what that is. So again, we're given a point, we're given the slope. We're kind of just served up on a silver platter, putting this in the form that we're asked to put it in. So that is what we're going to do. And then we're going to graph it using that point slope form. We don't have to convert to slope intercept form in order to graph it. We can graph it straight from point slope form. Let me remind you how to do that. So we're going to do y, this one may need a little bit of cleanup, y minus, I'm going to put in parentheses, you'll see y in a second, especially for the other one, y minus 5, that's the y1, right? And then this over here would be x1, equals m, which is negative 3/4. 3/4 times x minus negative 2. Now you notice this is why I went ahead and put this in parentheses on this first one, because here, in order to deal with this, we have to ka-chink that thing, right? And turn it plus. Okay, so our final equation in point slope form would be y minus 5 equals negative 3/4 times x plus 2. Okay. That's going to be easy peasy. So what we need to do in order to graph this is we're going to need to plot this point. So we're going to plot it, and you notice the signs are backwards. So we're going to go negative 2 and up 5 to start this. So negative 2 up 1, 2, 3, 4, 5. That's going to be our first point right there. And then we're going to count the slope. So we're going to count down, because it's negative, right? Down 1, 2, 3 over 1, 2, 3, 4. Down 1, 2, 3 over 4. Okay. Then we're going to connect the dots. Let's see. I think I can get me a relatively long-ish line right there. Since you have a straight edge, you could probably easily do this part as well, right? So there is that line. Easy peasy. I hope that you've seen this before, and if not, it's coming easy for you. If not, you can let me know in class, or you can let me know in our Discord server if you're in my class, or you can let me know if you're not one of my in-person students. You can always ask questions down in the comment section below this video. All right, let's do another example. We're going to write an equation. We're going to write an equation of the line through 0, 3 and negative 2, 1 in slope intercept form, then graph the line. Okay, so we're given 2 points this time. So we want this in slope intercept form, right? And so we need to know what the slope is. Okay, so what we're going to use to find the slope is we're going to use the slope formula. Slope formula, which is, in case you don't remember, is m equals y2 minus y1. So the difference of the y's over the difference of the x's. So x2 minus x1. Okay, so we can label this as x1, y1, and this one as x2, y2, right? That seems quite reasonable to me. You could do it the other way around. You just got to make sure it's consistent. Like this one's 1 and 1 and 2 and 2, or 1 and 1 and 2 and 2. It doesn't actually matter. Just keep it consistent. It's the probably best practice to do exactly what I just did and have the first point listed be point 1 and the second point be listed be point 2. That's just good practice. It's going to help keep you straight and organized. So the first thing that we are going to do is find that slope using that formula. So we're going to substitute it into the formula. I like to do just like I have always done and put parentheses where the variables are. That way we, like on that last example, we keep our signs straight, and we don't accidentally make sense there. So y2 in this particular case is 3. Oh, no, just kidding. Y2 I labeled as -1. Y1 is 3. At least I got the right variable, right? And x2 is -2. And x1 is 0. Now we're going to simplify this on down. -1 minus 3 is -4. And -2 minus 0 is still -2. And so this simplifies to +2, right? Because -4 divided by -2 is +2. Negative divided by negative have the same sign, so it comes out positive. So there is our slope. Now, we still don't quite have enough information because we're not in slope intercept form yet, right? We need to take care of that. So what we're going to do is we're going to use slope intercept form, this slope, and one of these points. If there's one of the points that has a 0 in it, that's a great choice. You could actually pick either point. Remember, for this next step, it could be either one. But I like to pick whichever one looks easiest. And it's almost, if you have one with a 0, go for that because it's liable to cancel something, which can be super duper helpful. So let me show you what I mean. Okay. So what I mean is we're going to write it in slope intercept form, which if you remember is y equals mx plus b, right? So we know the m. We just found it. So we're going to put a 2 right where the m is. We do not know the b. That's what we're looking for. So I'm just going to put plus b. We know an x we can plug in, right? We can plug in this x right here. So I'm going to stick a 0 right there in for x. And then if I'm using that point, then I need to use this 3 for the y. Now I just need to solve for b. Well, 2 times 0, of course, cancels, leaving us with just b equals 3. So our final equation in slope intercept form would be y equals 2x plus 3. Now we're going to graph that. It's in slope intercept form, so we're going to do it just like that first example where we start with the y-intercept. So we're going to start by going down 3 on the y-axis. Then we're going to count our slope. It's positive, so we're going to count up 2 over 1, up 2 over 1, right? So we're going to put some extra dots. I've got to do a little bit more mental things to give me a line, and then there it is. All right, we have 2 more examples, and then we are going to be through. How are we doing on time? We're doing really great on time. That's very good. I'm talking kind of quick. You may have to pause more in between, but that will be okay. You'll live. I think we'll still keep you in the 20-minute range. I need to pause just a second, but you will hardly notice. All right, like I said, you didn't hardly notice. So we're going to write an equation of the line through -2, 6, and 5 negative. Oh, that is a typo. It's not going to do what I need it to do for this example. So let me fix it. This should be 5 positive 6. There we go. All right, it's through -2, 6, and 5, 6 in slope intercept form. Then we're going to graph the line, okay? Easy peasy, lemon squeezy. Excuse me. So we got to do the same thing. We're going to find the slope using the slope formula. So we're going to do m equals the difference of the y's on top. So 6 minus 6, that should give us a thought and a clue right there, over 5 minus -2. So the first thing we'd have to do is ka-chink that right there. It's not going to make a lot of difference because 6 minus 6 equals 0. So this turns into 0 over 7, which 0 over anything is still 0, right? So our slope is 0. So let's finish this out, and it's you may, if you remember these, you may have already clued into where this is going, but if not, that's great because we're walking through it anyway. So we're going to plug it into slope intercept form, which is y equals mx plus b. We're going to plug in 6 for y. Either way, we're going to plug in 6, right? They're both 6. Equals m, which is 0 times -2 plus b. 0 times -2, of course, cancels out, which means that b is 6. So if we're plugging this into slope intercept form, and I'm going to walk this all the way through. You may already see where we're headed, but I'm going to walk it all the way through just so you really for sure see. That's the power of doing this in a video instead of doing it in class, is we have time to do stuff like this. Okay, so y equals 0. I don't know why I'm putting in parentheses. Don't really need it in parentheses. Hello. 0x plus 6. Now, 0 times x, of course, that's going to cancel again, right? Leaving us with y equals 6. So there's that equation of the line. Now, we've got equation y equals 6, which, of course, is a horizontal line at y equals 6. So this is going to look like this right here. That right there. Just like that, because y is always equal to 6. Now, it's worth noting, I didn't include an example of it, but if we would have ended up with finding the m equals something, doesn't really matter what, over 0, then the m would be undefined, which would mean it would be a vertical line somewhere. Okay? And it would be, the vertical line would be wherever that x piece is. Okay, so we've got one more example to do, and then we are through with this lesson. So you go away, you come back. You get a line, I get a pole, honey. Oh, wait, something. I don't know. Here we go. One last puzzle piece. This is where I was talking about. This is going to include stuff from the last lesson and this new lesson all in one puzzle piece. Okay, so we're going to write an equation in slope intercept form for a line perpendicular to y equals -3x plus 2 containing 4, 0, and then we're going to graph the line. So we need to remember from last lesson or algebra 1 or wherever else, what's true about perpendicular lines. Well, they have opposite reciprocal slopes. So we got to flip this sign and flip it over, right? So our m that we're interested in is positive 1 over 3. Now we've got a slope, we've got a point. We're going to put it in slope intercept form and roll on down the way. Okay, so let's do that. We're going to plug it into slope intercept form just like we've been doing this whole time in this video. So in for y, we're going to put 0. In for m, we're going to put our m, which is 1/3. In for x, we're going to put 4. And then we're going to put plus b because that's the one we don't know. Now, 1/3 times 4 is, of course, 4/3. 4/3 plus b equals 0. We need to do one more thing, right? Because we need to get rid of this 4/3. How is that 4/3 attached to the b? Well, it is added and it's positive. So we're going to subtract it. We're going to do its inverse to get rid of it. So we're going to subtract 4/3 from both sides. Those ones cancel, leaving us with b equals -4/3. I use that symmetric property to flip it around with the variable on left just because we like seeing it that way. So we're going to rewrite the full equation as y equals positive 1/3 x minus. Now I'm going to go ahead and write this as a mixed number because it's going to be easier to graph that way, because 4/3 is hard for our brain to wrap around. So -1 and 1/3. Okay, so there's our equation. Let's graph the thing. Whoops. Kind of made a mess of that, didn't I? I still kind of made a mess, but we can see it. No, I'm not going to do it. I'm not going to be lazy. We can do this. I can circle an answer. I did it. Are you proud? Let me know in the comments. Let's graph this thing. So we're going to go down. And in this case, actually, I'm going to kind of cheat, right? Because -1 and 1/3 and -4/3 is kind of hard to find. And so I'm going to end up getting off, and it's going to be ugly. And I'd rather it not be ugly. So I'm going to start from this point that we know lives on our line. Why not? Let's do it. Okay, so we're going to start at 4, 1, 2, 3, 4, 0. We're going to start right there. And then we're going to count up 1 over 1, 2, 3. And I like to put 3 points before I grab my straight edge. So we can't fit that on this graph provided. So we're going to flip it all the way around. So instead of going up 1 over 3 to the right, we're going to go down 1 and back 3. So see how we flipped all of it around and we still ended up with something useful. Okay, so I'm going to go down and put me a dot right there and right there to connect all of my line stuff. So there it is. Just for grins and giggles, it doesn't say to do this, but I'm going to go ahead and do it on this one just to kind of prove what's happening. I'm going to go ahead and graph this line as well, just to kind of prove that it is also perpendicular to this line. And I'm going to graph it from the y-intercept this time, because I'm not going to cheat and go to here, just to kind of prove that it does, this does in fact go through this point and is also perpendicular to this new line that we did. So I'm going to start at, let's do a definitely different color. Let's do this lime green one, I think will be great. So I'm going to go up 1, 2 and put a dot. And then I'm going to go down 3, down 1, 2, 3 over 1. That's that line right there. So you can see that they do in fact connect. I can even, let's do that a little bit better. Let's go up here, and then we'll see if we can go right. Oops, I keep messing up. 1, 2, 3. Wait. 1, 2, 3 over 1. 1, 2, 3 over 1. This one to that one. There you go. That was a little bit of a brain challenge. You can see that it is in fact perpendicular, which we can prove based on the slopes, and it does go through that point. And we could prove that algebraically, but this is not a proof lesson. That's coming quite soon. We'll see you in the next one. Bye-bye. Have a wonderful, wonderful day, night, morning, evening, all of those wonderful times in between. Bye-bye.